In this video, I'd like to talk about the idea of finding the slope of a line when you're given a table. So this table represents the coordinates of a line. We have different x values and their different y values. But if you were to plot these would all line up with each other. This would be a straight line. And so we need to figure out the slope of this line. And to do that, let's just remind ourselves the definition of slope, which we usually denote with the letter m. But slope is defined as the rise divided by the run. You could also define it as the change in the y values divided by the change in the x values. And a lot of times you'll see the slope formula when you're given two specific points as y2 minus y1 over x2 minus x1. But effectively, we're figuring out how much does the line go up and down, and then we're going to divide it by how much it goes left and right. So in practice, what we're going to do here, because we know the slope is constant. So let's first look at these x values. Notice that they're always just increasing by 1. And so we need to figure out what's going on with the y values. Because it's going to be a constant rate, the y value should add or subtract the same amount each time. And notice we go from 21 to 17, so we are actually going down 4. And from 17 to 13, again, down 4. And from 13 to 19, we're going down 4. So this pattern is consistent. Every time we go up 1 for the x values, we go right 1, we go down 4 for the y values. So our slope here, m, is just going to be minus 4 for our rise, because our rise, remember, deals with our y values. So, or the change in the y values. And the change from one point to the next is down 4. And the x values are changing by going 1 to the right. So our run is just plus 1. Or in other words, our slope is minus 4. And if you were to plot this, you would see a slope or a line going downward fairly steeply. But the general strategy here is just to figure out what are the x values increasing by or decreasing by, and then look at the y values. What are they increasing or decreasing by? And then just take your change in y values, your rise, put that in the numerator, and put the change in the x values, your run, in the denominator, and then just simplify that fraction. So let's try another problem. And we're going to apply the exact same strategy. So let's first look at these x values and figure out how much they are increasing or decreasing by from one point to the next. And since we're going from minus 4 to 1, that's up 5. 1 to 6 is up 5, and 6 to 11 is up 5. So we're making jumps of 5 here. And the y values, it looks like we're making jumps of 1. So from minus 3 to minus 2, that's just up 1. Minus 2 to minus 1 is up 1, and minus 1 to 0 is up 1. So using our slope definition, letter m, we're dealing with our rise divided by our run. Well, our rise is just plus 1. Or our change in y values is just going up 1 every time. But our change in our x values, it looks like we're going up 5 every time. So this would be plus 5. So our slope here is simply just 1/5. And if we were to plot this, what you would see is a positive slope, but it's not a very steep line. So it might look something like this. For every 5 you go over in the x direction, you would just go up 1 in the y direction. So let's do a couple more of these. So again, we're just looking at how much do the x values jump by, and how much do the y values jump by. So notice x is going from 9 to 13, 13 to 17. So every time we're making jumps of 4. So in all these steps, it's constant jumps of 4. And for the y values, minus 24 to minus 21, we're going towards the positive numbers. So that means we're adding and we're jumping by 3. And from minus 21 to minus 18, same thing. And for this last interval, again, we're just adding 3. So now our slope, m, our change in y values, our rise divided by our change in x values. Our rise, we are going up 3 every time. So our y values are changing from one point to the next by 3 in the positive direction. So they're getting bigger. We're going up towards positive values. And our change in x values every time from one point to the next the x values are jumping by 4. So plus 4 here, and we can just drop the positive signs, and so you get 3/4 for your slope, which is almost like a slope of 1. So it'll be somewhat steep going up the mountain as we march to the right, but effectively every time we go 4 over, you would go up 3 for the y values. And moving on to this problem, this will be our last one. So same strategy, we'll just see what are we jumping with for the x values, and it looks like every time we are going up 3. And for our y values, it looks like we're going down a significant amount. So 36 to 12 would be down 24. And from 12 to minus 12, also down 24. And this last interval is the same. So every step for the x values, you're going up 3 units. And every step for the y values, you're going down 24 units. So our slope here, our change in y values over our change in x values. For the y values from one point to the next, they are changing by going down 24. For the x values from one point to the next, they are changing by going up 3 from one point to the next. So minus 24 divided by positive 3 would just be minus 8. So our slope is negative 8, or negative 8 over 1 if you'd prefer. Sometimes writing your slope as a fraction helps because it matches up with the definition of rise over run. So basically this is a very steep downward slope, but every time we go over 1, we go down 8 is essentially what this slope means. So it's very steeply going downwards.